We have already mentioned extreme events, extreme heat events, for example. There are also extreme rainfall events. I always like to explain it this way. As we said, as the atmosphere gets warmer with global warming, it has higher capacity to hold moisture. So you can think of atmosphere as a sponge, and you pour water on a sponge, it soaks it in. And if you push it with a finger, it will not drizzle. It'll begin to pour in some place based on the complex fluid dynamics that goes on within. Okay, so that's kind of what happens when you load up the atmosphere with a lot of moisture. There are instabilities which produce rainfall, and those instabilities act like somebody's pushing it a sponge, and you get rainfall that is extreme. So it could be like more than 100 millimeter per day, 150 millimeter per day, or it could be the 95th percentile of the rain in that region. So if you take some region that's relatively dry, let's say somewhere in northwest India or parts of Africa, the rainfall occurs at a certain rate, and once in a while they have a very high rainfall amount. So if you look at the distribution, you can find the rainfall that is in the top 95th percentile of the distribution. So the rainfall can begin to occur in that range with global warming. So if before that heavy rain was happening only once in 100 years or 50 years, with global warming, now it will probably begin to occur not everywhere but in some places, with a probability of once in 10 years, once in 5 years, and so on. So we call that before the loading of the climate dies by global warming. So some numbers begin to get thrown more often. Okay. The other side of this story is that there are some places which are dry, and they evaporate and supply water to the places that are rainy. Those places tend to get drier because there warmer air, like over California, it's a fairly dry place. Warmer air will begin to dry out the soil and the vegetation faster. Okay, so you have extremes on both sides, and there are other details of the dynamics which show us that the droughts can also rapidly grow, and they're called flash droughts now. Usually droughts are kind of a slower growth than floods, which come with heavy rain, for example, right? So those kinds of things have to be considered. This map basically shows minus 28% to 28% per degree global temperature rise. So what they have done is to take the trend in the logarithm of the wettest day of the year as a multiple of the global mean temperature rise. So that gives you a sense of per degree rise, what is the extreme event increase you are getting. So here is the scale going from minus 2.8 to plus 2.8, and the statistical confidence is shown as well. So you can see that some places are getting wetter, much wetter with each degree warming. There are dynamic details about why some regions don't respond. So here it's actually getting drier with each degree of warming, whereas in some places it's getting wetter but with different degrees, so 10% to 28%. There are lots of increases in wetness or extreme wettest day of the year here or parts of India, but you can see that India has a complex scale of drying and wetting. Why? Because it's surrounded by the ocean. Land can warm faster because it has a lower heat capacity, but the ocean is also warming and it can pump in the moisture. So when land warms and demands moisture, the moisture has to be brought in from the ocean most of the time. Kind of, I'm just giving you some intuitive feel for the kind of processes that go on. At higher latitudes, this also includes precipitation, so it can be snowfall, not just rainfall. Okay, Anyway, those are the kind of things. This one we already looked at, where in terms of the heat wave days. So this is the trend from over the period of some number 1980 to 2013, or whatever the number we mentioned before. So we looked at heat wave days in days per decade, length of the longest heat wave in days per decade, average intensity of degrees centigrade per decade, cumulative intensity, as we saw. So that comes from there, that you can go and look at. This one is now showing annual probability of occurrence of extreme humid heat waves at 4-degree warming relative to 1861 to 1880, which is likely by 2070 with a particular scenario of warming. So that sounds very complicated, but it's actually fairly straightforward. We are doing humid heat waves to remember that not just the temperature, but the increase in humidity matters as well, as we saw with the wet bulb temperature table, right? So here the probability of the increase in 4-degree extreme heat waves is being shown, and this is for a particular temperature that will be accomplished in RCP 8.5. We haven't gone into those details. The future scenarios by the Intergovernmental Panel on Climate Change did 4 scenarios. They are called representative concentration pathways. They look at various assumptions on population growth, renewable energies, transportation options, other technology advances, and so on, and compute future scenarios of how much additional warming will be created by the emissions related to those scenarios. They are called representative concentration pathways. So instead of tracking the amount of carbon, they look at the additional forcing in terms of watts per meter squared. So sun's energy is coming in, infrared energy is going out. Global warming is caused by basically trapping of the outgoing energy by the greenhouse gases. That's what they do. Okay, they are good for us, but when you increase them, it's not good for us because it causes warming and melting of glaciers and so on, right? So this is the level of 80 apparent temperature 55 degrees centigrade, which roughly corresponds to a wet bulb temperature of 33 degrees centigrade, with peaks exceeding 35 degrees centigrade. 32 degrees centigrade of wet bulb temperature is what we considered dangerous for humans because the body is unable to get rid of the humidity. Long story short, there is disparity again. Some places will get into dangerous territory, and global south has lots of those regions, especially India, as we saw before, has the highest number of additional extreme humid heat waves in any scenario, which is not good. So even if the monsoon gets better, if it comes with extreme humid heat waves, then it's going to have serious health outcomes and labor lost, etc. Okay, so since this became a little bit complicated than I expected, I'll do the floods and droughts in the next podcast, but make sure you understood the extreme events. We're talking about rains, which cause floods and dryness. We're talking about heat waves, which are also associated with increase in humidity and humid heat waves. That's what you have to remember.